Continuing with your module 5. Okay, so we are done with there are two chapters. The first one is related to signals, and the next one is related to Daemon process. Okay, so today we'll discuss about Daemon process. So Daemon are the process that live for a long time. Okay, so it's a process, but it lives for a long time. They are often started when the system is bootstrapped. So when you boot the system, okay, they will be the Daemon process will start. Okay, and they will be terminated only when you shut down the system. Okay, so here few points you have to know about Daemon process is that uh, they run in the background. Okay, they run in the background. Say they don't have any controlling terminal. Okay, they don't have any controlling terminal. And in Unix system we have numerous daemons. Okay, they perform several day-to-day activities. Okay, so here we will learn some daemon process characteristics. Okay, so if you execute ps command, okay, so similar to your echo command, we have studied several commands in our module 1. Okay, like cat, cp, so on, different commands we have studied. So here if I type ps command, so this ps will give you the process status. Okay, ps stands for process status. So it will print the status of various process that is running in the system. Okay, so here for example if I type, okay, ps, okay, and there are several options. Okay, along with ps there are several options like so we know that options will start with minus. Okay, here we have options like a, x and j. Okay. So here minus a option will show the status of the process owned by the others. Okay, so that is owned by the others. There are three types of groups, right? Owner, group and others. So here it will print the status of the process owned by the others. Okay, and minus x shows processes that don't have any controlling terminal. Okay, so this will give you the daemon process. Okay, so minus x will give you daemon process. Okay, they don't have any controlling terminal. And minus j option displays job related information. Okay, so here it will give you the session id, process group id, controlling terminal, terminal process group id, so on. Different job related information will be displayed. Okay, and similar to these options, okay, there are different other options. So these options comes under a type of operating system, that is BST Unix operating system. Similarly, if you go for other operating systems, okay, versions of Unix, we have other different options, okay, to display the daemon process and their activities. Okay, so we have an example here. Okay. So you can see here, so this diagram, this tabular diagram shows, okay, the output from the ps. Okay, so what will be the output? So we have few columns here. Okay, so not only restricted to these columns, okay, there are other few columns also. Okay, so column headings like we have parent process id, then we have process group id, so this stands for process group id, session id, terminal name, so this will give you the terminal name, then this will give you the terminal process group id. Okay, then this is for user id, okay, and this is the actual command string. Okay, so here you can see there are different parent process ids, 0110011, and here 1405. Here if you see the process is 0, 1 and 2. Okay, So these three are special and exit for the entire lifetime of the system. Okay, if the process ID is 0, 1 and 2, they are the special process. Okay, and their lifetime is entire lifetime till you shut down the system. Okay, and if you see, okay, if you see this 1, 2, yeah, this if you see 1, 2, okay, here, okay. So here if you see this, okay, process ID 1, okay, they have parent process ID 0, and if you see their group ID, session ID, then user ID, everything is 0. Okay, everything is 0. So this is a special process. Okay. And if you see here, these are all Daemon process. Okay, and as I already said, they don't have any terminal. Okay, here they don't have any terminal names here. All are question marks. Okay, so this is important when you write in the exam. So they don't have any terminal names. Okay, so terminal name is set to question mark, and at the terminal foreground, uh, process group is -1. You can see here, process group ID is what? All are having -1. Okay. Okay. So this is about a Daemon process and some coding rules. Okay, how you can code, okay, to create a Daemon process. Okay, we know that how to create a process, like if you just execute fork system call, it will create the process. Child process will be created under a particular parent. So that we saw how, with the example, okay, how to create a normal process. Okay, now you have to learn some coding rules, okay, before creating the Daemon process. Okay, so here the first thing is to do is to call unmask. Okay, we know that unmask is to set the file mode creation mask to 0. Okay, so this is what you have to run first. Okay, so set the file mode creation mask to 0. So what is this file mode mask to 0? So file mode creation mask that is inherited could be set to deny certain permissions. Okay. And if the daemon process creates file, it may want to set specific permission. So what we do here is unmask means file mode creation mask is equal to 0 means you are deleting all the permissions for a particular file. Okay, so you have different types of permission for the files, right? Read, write, execute and all. So all those permissions will be set to 0. Okay, then based on the requirement, this daemon process can create the file and they can set the specific permissions. Okay, for example, if it is specifically creates a file with the group read and group write enabled, a file mode creation mask that turns off either of this permission could undo its effort. Okay. So the next coding rule is we have to call, okay, you have to use the same system call, that is fork. Okay. And what we have to do is you have to have exit. Okay, so here what we do is usually there will be a parent process. We use a fork system call. Okay, we use a fork system call, and this fork system call will create a child process. Okay, now once you create this process, child process, what we have to do is you have to exit. Okay, you have to terminate this parent process. Okay. So when you exit a parent process, this does several things. Okay, so there are two things here to remember. First thing is, if the daemon was started as a simple shell command, having the parent terminates make the shell think that the command is done. Okay, then what happens is, when you when you call this exit for the parent, okay, what will happen? Okay, so the parent terminate makes shell. Okay, so shell, what will happen? Shell will think that the command is done. Okay, this fourth command is done. The second thing is, the child inherits the process group ID of the parent. So this child will what will have? It will be having the process group ID of the parent. Okay. So it will be having new, it will be inheriting the process group ID, but it will be having a new process ID. This you remember, process ID will be different. If this is 100, this will be having some different process ID. Okay. Only thing is, this child process will have the same, it will inherit the group ID of its parent. So if this is a group ID, okay, G100, okay, then this also will have the G100 as a group ID. Okay. So since they are having, okay, since this child is having the group ID of the parent, okay, so we understand that the child is not a process group leader. Okay, we understand that this is not the main process. There is some main process from which it is inheriting. Okay, so this is the point you have to remember. Okay, the second point, while creating the daemon process. Third one is, we have to call a special function, that is a set SID, okay, to create a new session. Okay. So you have to create a new session for the daemon using this. Uh, so three steps you have to follow. Okay. So three steps you have to follow here. First one is, the process, okay, becomes the session leader of the new session. Okay, the new process you have created, that will become the session leader. Okay, that daemon process will become the session leader of the new session. The session, you know, right? A session is nothing but for a particular period of time duration. Okay, maybe from 9 to 10 o'clock. So there is one session. Okay. So the daemon process can uh, perform certain tasks using this particular session. So now this daemon process will become the leader of this new session. Okay, it becomes a process group leader of the new process group. Okay, and controlling terminal. Okay. The only thing is, it will be having only the control of the session, the new session. Okay, but it will not be having any terminal. Okay. So create here daemon process, and the daemon process will be given with a particular session to execute. Okay, and here whatever the parent process we have created, that it should be executed. Okay. The next one is change. Okay, the change current working directory to the root directory. So you have to change the current working directory to the root directory. Fifth point is, unneeded file descriptors should be closed. Okay, suppose if you have created the file descriptors like opening the file or reading the file, where you create file descriptors. Okay, whenever you try to read a file descriptor will be created. It's like a pointer to the file. Okay, once okay, everything is done. Okay, this all the 4 steps are done. You have to close all the unneeded file descriptors. Simply, you can, if this is a file descriptor FP, you can simply call close. Okay, and you can pass this file descriptor and you can close the file descriptor. This prevents, okay, Daemon from holding open any descriptor that it may have inherited from its parent. So any file descriptor, if this Daemon process is inheriting from the parent, can be closed. Okay. And the last point is some Daemon opens a file descriptor 0, 1 and 2. Okay, to this particular file, so that is hash view hash null, so that any file or any library routines that try to read from the standard input or write to the standard output, okay, or standard error will have no effect. So look at the example here. Here, similarly, so this is the program to create the initialization of the Daemon process. Okay. So in the exam, they may ask you how to initialize the Daemon process. Explain with the code. Okay. So these are the header files we need. Okay. If you see here, this is not a main program. This is a subprogram, okay, where this is function. Okay. Daemon initialization function. So this initialization function, we will be having the code for initializing Daemon process. Okay. So program is a function that can be called from a program that wants to initialize itself as a daemon process. Okay. Now here, what we are doing is, so as we saw all these 6 points. You can see here we are using fork system call, and we are using this set ID. We have to go for exiting the parent. Okay. So all these things should be done here. So here, okay, we are creating a process. Okay, we are creating a process. This is our main process. We are creating a child process. Okay. And now once at some point of time, okay, some point of time we write the code to exit the parent. Okay, that is what should be done in the code. Okay, you have to exit the parent. Okay, this is exiting the parent, and once the parent exits, the child will continue. What the child should do? Child should create the new session by using this function call. So here, this is a set SID. So this is a function that will create the new session, and now the daemon process will become the session leader. Okay. So this child parent will be exiting. Okay. Now this is a daemon process, and they will be having particular session, and it is a session leader. Okay. And here, this is a function, okay, which we use for changing our current directory to the root directory. So this is, okay, we are changing our current directory to the root directory. Okay. And third thing is we already saw in the first step. Okay, you have to unmask. Okay, and you have to delete all the permissions. So that is done using this building function umask. So what umask will do, it will delete all the permissions set to a particular file. Okay, so the parameter what you pass should be 0. So few points you have to remember here. The first thing is, okay, so this is a parent ID. At particular point, okay, the parent ID should be parent should be you have to exit the parent. Okay, this should be done. That is the first point. Second thing is, for the child, the session should be created. That is the second point. And you have to change your current directory to the root directory. And the fourth one is, you have to delete all the permissions for all the files. So these things you have to remember. Very simple program. Okay. So these 4 points should be explained in the coding rule. So you can create a main program, and in the main program you can call this Daemon initialization function. Okay, and you can check the status of the daemon with ps command. Okay. So next one is error logging. So one problem in the daemon process is how to handle the error message. Okay. Sometimes something may go wrong with the daemon process. Okay. It may throw an error. In that case, how to handle the error message. Okay. So you cannot simply write to the standard error. Okay. You have different three types of files, right? Standard error, standard output, and standard input files. You cannot, in this case, you cannot simply write to the standard error. You cannot display it in the terminal because they don't have any controlling terminal. Okay. So if for example you are trying to list the file, okay, and if the particular file is not there, what will happen in the terminal? Also, terminal itself, it will throw the error telling that this particular file is not there. But in this case, okay, this is a special process which don't have any controlling terminal. Terminal have there is no relation with this. Okay. So in that case, how to display the error message? Okay. So here, we have different daemon process. Okay. One thing is we don't want each daemon process to write its own error message to the separate file. That is not necessary. Okay. So if there are 100 daemon process, and if the 100 process write to the separate file, 100 separate file, then it will be a big headache for us to, or for the system administrator to look into those log files, 100 log files, and check what is wrong with those daemon process. So that is a headache, correct? So in that case, you can go for a central daemon error logging facility. Okay, so there is a special facility available. Okay, that facility is called as Central Daemon Error Logging Facility. Okay, so here in this, so there are two topics we are discussing. One is SVR4 stream log driver. One more is, okay, so there are two types of our main operating system version we are discussing. Okay. Here we'll be discussing about there are two types of SVR stream log driver. Another one is BST SYS log facility. Okay. So here we'll be discussing one logging facility, that is BST uh, syslog facilities, okay, which is widely used in BSD version of Unix. Okay. You can see here there are three ways to generate the log message. Okay. So you can go through this diagram. First thing is the kernel routine. Okay, the kernel, this is a kernel. Okay, so this is a kernel, and inside this kernel we have different um, files. Okay. You can see here this is a kernel routine. Okay. The kernel routine will call the function that is called as a log function. Okay. This message can be read by any of the user process that opens and reads the this particular file. Okay, so first thing is what? So you have a kernel routine, okay, which uses this particular function. So this particular function will write the okay, error message to this particular file, that is the file which is there in the path /dev/klog. Okay, and this device file can be read by, okay, can be opened and read by any of the user process. Okay. Next one is most user process, okay, can call this log. Okay, this is a user process. Any user process, okay, any program. So whenever a program is executed, a process will be created, correct? So any process can call a function called as this log function to generate a log messages. Okay, so this is one log function. This is one more function, this log function. Okay. So that can be used to generate the log message. Okay. So this will cause a message to be sent to the Unix Daemon datagram, that is socket, which we call it as. So here in this part it will be writing all the, so this is a device file in which the user process can read this files which is there in this particular path, that is called as Unix domain datagram socket. Okay, so in this part it will be storing all the error messages. So you can use the files which is there in this particular device path, and you can access those error messages. Okay, so that is the second way of generating the log message. The third one is, okay, third one is a user process on its host. Okay, any user process. Okay, or any some other host that is connected to the host by using TCP. You can go through this. So any other system which is connected using TCP/IP network can send the log message to UDP port 514. So this is a port 514. Okay. So they can send the log message to this port. Okay. And once this message is sent to this particular port, then you can use this syslog function. Okay. So here, while writing, okay, to the log file, we need explicit network programming by the process generating the log message. Okay. Once it is done, okay, using this port, you can generate the log message. Then, using this particular system called syslogd, you can read all these three, okay, all these three log messages. Okay. So there are three ways. Okay. First one is the kernel routine log, and they can write the all the log error messages, Daemon process message error messages to this particular file. Second one is using this function. Okay, using this function, they can write the all error message to this particular file that is there in this path. Okay, the third one is you can make use of this particular port, okay, and this particular port you can write this error message. Okay. Normally then this log D, so this is one more daemon, okay, this log D. So this is a daemon that reads all three form of error messages. Here, here and here there are three error messages. So all these error messages can be read by this daemon process. This daemon reads the configuration files on startup, usually using this particular configuration file. So there is a particular configuration file that is etc, okay, slash syslog, okay, syslog dot config. So this is a configuration file that can be used, okay, to read the error messages. So write the file or to the logged in user or send to another host. Okay. So once you read you can read all these error messages which is there in this particular files. Okay, and you can either write to another file or you can display user. Then you can see here you have an interface. Okay, an interface that is a syslog function. You can see this is a function, built-in function. Okay. So this function is necessary, okay, to create. So here we said that there is a syslog function. So we can go to those function, okay, syslog function. So here in the syslog function there is two parameters, that is priority, okay, and the format. So these are the two. And there is one more optional system call that is open log. It's an optional, okay. So when the first time we are calling this function syslog, okay, open log is called automatically. So this will be called automatically, okay. And close log is also optional. So these two are optional, okay. Then close log is also optional. It just closes all the descriptor that was being used to communicate with the this particular daemon. Okay, so this particular daemon. So when you call, okay, so when you call open log, okay, API, so here it will let you to specify, okay, IND. So that is a message that is to be added to each log message. Okay. We can simply write these three APIs which is required for reading the error messages. Okay. So apart from this BST version, there is one more version that is SVR4 stream log driver. Okay. So that is one more version of Unix. Okay. And they have their own way of reading the log files, error log files. Okay. So there also they write the log messages, okay, using different, we are using different functions there. Similar to here, we are using log, syslog and all, right? Same way there we are using different like str log function, okay. So in this version, okay, in the version SVR4, okay, this is one version SVR4. Okay, so in this version, we are using a message that is str log. So this is a function that is used to write the error messages to different files. So there are different files, log files. Okay. So for example, slash view, that is device log files, slash view slash log. Okay. And similarly, we have slash view slash configuration file. Okay, so there are different files are there. To these files, it can write the error messages, and you can read this. Okay, you can read this files using different functions. Okay, for example, you can use get message. Okay, so this is a one system call that is used in this version SVR4 Unix version. Okay, and this can be used for reading the error messages which is there in this particular files. Okay, and you can either display it or you can send it to a particular file. Okay. So the last one is, there is a simple last topic, okay, client server model. Okay. So here a common use for a Daemon process is a server process. Okay. You can see here, okay, we say that this is a server process. This log D, it is a daemon process. It's a daemon process, okay, which can be called as a server. We can think this as a, in this diagram, we can think this as a server. Okay. So if they ask you for more marks, you can view this diagram as a example and you can explain. In this, this is a daemon process which can be thought as a server. Okay, and this server has a right to send messages. Okay, it can send the messages to its user process. Okay, so there are different user processes. It can send the message to its user process. Okay, this is a daemon process. It can send the message to its user process. Okay, which can be called as a client. Okay, see here, this diagram clearly explains the logic of server and client relationship. We know that basically you have studied in networks, right? Client and server. So what happens in client and server? So client can request, okay, the server to give some information. The server is like a main process, okay, that can process the request that is coming from the client, and once the process is done, it can send the response to the client. Correct. The same way here we can treat this daemon process as a server and all the user process as a client. Okay. Now this daemon process can send the messages to the client user process using this Unix domain datagram socket. So this socket can be used to send the messages to the client. Okay. So here what happens is client is the one. So client is the one which waits for, server is the one, is a process that waits for the clients to connect it. Okay. So what happens? So server will be keep waiting, correct? The same as the logic of your networks. Server will be a process here. It is waiting for the client to request some data, correct? It will be waiting. Okay. Once it gets a request, okay, the requesting some type of service, okay, the service will be processed by the this particular server. Okay, service being provided by the, okay, this log the server is a logging of an error message. So what this will give? So this will be giving the service, okay, in terms of logging error message. Okay. So there is server, there is client. So what is our server? It is a daemon process. What are the clients? They are the user process. Now daemon client will be requesting the service. What is the service it is requesting? To view some error message. Okay. Some error messages, log error message file it is requesting. Then daemon process, okay, which is a server, based on the request, it will be sending the error message, that is the log error files. Okay. So this diagram clearly shows the communication between the client and the server. Okay. In one way, okay, the client just sends its service request to the server. The server sends nothing back to the client. Okay, sometimes it will not send anything. Okay. So this is a simple client-server relationship that is shown. So we don't have much explanation for client-server model. Only this much is there even in the textbook. Okay, which shows when they ask you have to draw this diagram. Okay, so in the diagram you have to explain this is a server, this is a client. Client will be requesting for the log files. Okay, for getting displaying the error messages. Okay, then server what it will do? It will communicate with these files. Okay, and it will give those error log files to the client. Okay, so this is all about your module 5, the simple chapter. So let's go through few our fourth module and fifth module, few question paper questions. Okay, so this is not actually your question paper, your scheme question paper. You can see here this is 10th scheme question paper. Okay, so even in 15th scheme, these topics were not there. Okay, so if you want, you have to refer to this 10th scheme. So here we will go through our fifth module. Okay, so just to brush up what and all we have studied in fifth module. So in the fifth module, we studied about signals. Okay, signal mask, very simple. Okay, your fifth module is very simple, not lengthy. Okay, compared to other modules. Signals, signal mask. Okay, how the signals will be handled and how we'll be sending based on the signal how you get. Okay, how we get the signal, we'll be performing certain actions by calling the signal user handler functions. Okay, then what is this cd child signal? And we saw about the signal, setting the signal and jumping to the particular user defined function based on the signal we get. Then how to call the LDRAM signal. Okay, this is setting the LDRAM, how to call the LDRAM signal. Then based on timer, by setting timer, we will be calling the alarm signal. Okay, so this is, there are two types, interval timer and POSIX 1B timer. So this is used to call the alarm signal based on the timer. Then about the Daemon process. Okay, how we can, what are the characteristics of a Daemon process? How we can create or how we can write the code for creating the Daemon process, and where the error log files will be saved. Okay, and how you can access those error files. Okay, what is the relationship between the Daemon process and the user process? How the Daemon process act as a server and how the user process act as a client, and how you can interact, how this two process, okay, that is inter-process communication can happen between these two processes for accessing the error log files. So this is a summarization of your fifth module. Uh, so I will explain. Okay, we shall go through our third and as well as fifth module questions. Okay. So in the third module, what and all we have studied? We studied about file APIs. Okay, and we studied about some uh, how to create the process and process termination, how the process will be terminated, and some memory related concepts. Okay, what is the kernel support for process and process control we started, correct? Process discussion we started here in our third module. Okay, fork and v fork. Okay, race condition, what are the different types of exe functions, wait functions, and all we discussed in our third module. Okay, so let's go through few question paper questions. Okay. So here you can see what is describe the Unix kernel for support for files? What is the relationship between hard link and symbolic links? Okay. So you can see here we studied about symbolic link files, correct? So there we will be studying about hard links and symbolic links, and importance of file and recording locking. Okay, we studied what are the different types of lockings, right? Read lock, write lock, and different versions. Okay, exclusive lock, shared lock, and all. Okay, what is the importance of that? Okay, and we saw how the lock. Okay, how we can use this API. File control API can be used for file and record locking. Okay, so this example is there. Okay, we already discussed about this. Then there are few other questions, okay, which is not related for us. Then memory layout of our C program, okay, malloc, falloc, stack and all. So that is diagram is available. Okay. And here you can see here we have set to jump and long jump function that we discussed in our third module. Nothing. Yeah, third module we discussed about set and long jump function. Okay. And this is our fifth module question. SIG action function. Okay, what is about kill? What is alarm API? What is a Daemon process? What is its characteristics? Okay, so this is our fifth module question. Okay, and so this is one more question paper. This is about third module. Okay, third module, different APIs, open, LC. Okay, so this is about third module. Again, this is about third module, locking files. Okay. What is advisory lock? Okay. What is mandatory lock? So, like these questions will be asked. Okay. Memory layout. What is environmental variable? Command line argument. Okay. How we can terminate the process. Then what is fork and v-fork? Okay. What is the difference between fork and v-fork? And here sig pro mask, sig action, alarm, kill, okay, Daemon process, error logging facility supported in the Daemon process. Okay. Then, so this is fourth module. Okay, this is fourth module. One more question paper we'll see. This is one more question paper. So all this question paper I will share in Teams. Okay, you can go through that. So you can see here what is uh, what are the different APIs. Okay, these are the different APIs. Symbolic file linked APIs. Okay, then starting okay, memory layout. If you see most of the question papers, we saw memory layout. Then exit. There are different types of exit functions. Race condition, exe function, signals, signal mask. Okay. Daemon process, coding rules for the Daemon process. Okay. So like these questions will be asked. Okay, most if you go through this, you can understand most of the questions are direct questions. Okay, you have to study all the prototypes. Okay, you have different prototypes. Okay, for different API functions, you have to study those all prototypes. Okay, don't keep for the last minute. Okay, so you will be having your final exam, which will not be in online. Remember, okay, it's an offline exam. So quickly answer your attendance. If you have